Now, if we put a real-life situation to this, there are actually many real-life situations that are modeled well by radical equations, such as roller coasters. Using a physics equation that's been altered a little bit, v equals v naught squared plus 2ad, very similar to one that we would deal with physics, except that one had two squareds. This is just a manipulation of that. What we're looking at is trying to find the unknown, as it always has been. We have v being the final speed of the roller coaster, likely at the bottom of the drop. v0 or v naught, that would be the initial speed of the roller coaster at the top. A being the acceleration of it, d being the distance that roller coaster has to go. So what the design says of this roller coaster is that the speed is 120 feet per second at the bottom. That would be v. The initial speed at the top of the roller coaster is 10 feet per second. And the acceleration, because the roller coaster just coasts, it doesn't have an engine of its own, the acceleration is 32 feet per second. What should the vertical drop distance be? We're trying to solve for d. So if we take that equation, we substitute in what we know. We know that v is 120 feet per second. We know that v naught, the initial speed, is 10 feet per second. A, 32 feet per second squared, and d is what we're trying to solve for. Difficult to type this into the calculator as is, so we'll do a little bit of work by hand first. 120 isn't going to be touched. 10 squared is 100. 2 times 32 is 64, so we get 64d. Again, with all radical equations, solving by the calculator, we need to have a 0 on one side. So we'll subtract 120 from both sides. And we can go and type that into the calculator. So square root 100 plus 64, and we can't type a d into the calculator. We can type an x in, close the bracket there, minus 120. And when we graph that out, we actually get nothing on the screen. That's because the graph of this equation doesn't exist in this small window setting. So we can go and change the window settings manually by pressing window, but we have absolutely no idea where this graph crosses the x-axis. So the better way to start this would be to have the calculator take a guess for us. So we'll go to zoom. We actually want to do zoom fit, which is way at the bottom of the menu. It's option 0. Zoom fit allows the calculator to give us what it thinks is the best window settings, and then if we need to, we can manipulate them later on. So it's going to think for a moment, and it's going to give us the graph here. The problem is, with the way the calculator is given this to us, we don't actually have the x-axis showing. That's a necessity. So now we can go back to the window settings. The x-axis is where y equals 0. So we can see y min, the lowest point on this graph, is negative 117. Y max, the highest point, is negative 92. So I'm going to change this a little bit. Go with some nice numbers, let's say negative 100. And we definitely need to get above the x-axis, so let's try 50. And we'll see what happens. And we can see a little bit of the graph right here. It's climbing up, but we don't see enough of it to cross the x-axis. So what we need to do is we need to change the x max so we can go further to the right and see exactly where this graph crosses. So I'm going to change the x max. Let's try 50 and see what happens. Clearly not enough, so let's go a little bit more. Let's try 100. And again, we're getting closer, we're just not close enough yet, so let's try 300. And that's good enough. We can see the graph crosses the x-axis right here, and now we can go and solve. So second trace, option 2 again. Left bound, as long as we're to the left of the x-intercept, we're good. That's where we are. Right bound, we've got quite a bit of moving to do. That looks good to me. Move back to guess. And we get 223.4375. Looking at the question, question's asking this for us into the nearest foot, so we would have 223 feet. That is how tall this roller coaster must be in order to give the desired speed at the bottom.